The first step in putting the DNA replication foldable together is to gather your materials. You need a half sheet with directions that says DNA replication, which is on the left, and you also need the cutouts, which is the paper on the right. In addition, you will need your notebook, which you are going to paste or tape this into. In the directions, step 1 says to cut out diagram A along with the crossed out circles on the shaded tabs of the diagram. Diagram A is the one on the top. When you are finished with diagram A, it should look like this. The circles are cut out and the outline is cut out. Step 2 says to cut out diagram B and fold along dotted line. So diagram B is the one on the left. On the shaded tab only, cut the solid horizontal line marked cut. So that is this one that is right up here. And then cut the 4 dashed lines, making sure not to cut into the circle. And so you're going to cut these dashed lines, but you're going to leave the circle intact. Fold back the tabs that were made from the cut and repeat with diagram C. Okay, here is my finished tab B or side B. Notice that when I cut it, I can fold it in half like this. We were only supposed to cut on the dark side, the shaded side, this part right here. This side we still leave connected together. Do not cut that side. If you cut that side, you're going to cut off your tabs. When we're done cutting the horizontal line, then I just go through and I basically cut the shade or the dotted lines that were on it. And so now what happens is when I fold it, I have this little tab that's going to fit into our part A in a few minutes. So this is what your finished, if you did it correctly, that's what your finished side B, diagram B should look like. Finish the diagram C the same way. You're going to cut it the same way, making sure only to cut the solid line and the dotted lines. Do not cut the one that goes down the middle. Step 3 says to insert tabs from diagram B into the left side of diagram A and repeat with diagram C, this time inserting tabs into the right hole of diagram A. Both pieces should now rotate easily. So what that means is that I take B, which is on my left side here, and I'm going to fold it, and I have this little tab. What's going to happen is I am going to put the little tab, and I'm doing this one-handed, so I'm going to let you guys do it. I'm going to put the little tab through that hole so it stays there. I'm going to do the same with the other side. I'm going to fold it in half. I'm going to take this little tab here that I made and I'm going to stick it through the hole on the right side with part C. I'll show you the finished product in a minute. Okay, here is the flap and you can see how I put it in. Okay, so basically I took the top and the bottom part of the insert and I stuck it through, and so on the other side you can see them coming out on the other side. Okay, and this is what it should look like. And now you can see that when it rotates, or it can rotate, it can move back and forth and still stay in there. So do the same with the other one. When you are finished with step 3, it should look something like this, where it looks like one DNA strand going all the way down. We have 2 sides to it. And now we're going to be ready for step 4. Step 4 says using the key below, well, it's actually going to be on the side here to the right on your directions. That key right there. Identify and color each structure of the DNA molecule. Color your DNA molecule according to the colors used in your key. Cut out the key and paste into the Science Interactive Notebook. This is going to go on page 80 of your notebook. So whatever color I color the S there, every time I see an S on this sheet, I'm going to color it the same thing. And hopefully you guys remember, S will stand for our sugar, P for phosphate, G for guanine, A adenine, T thymine, and C cytosine. Okay, you can see that I've started coloring according to the key I made. I don't care what colors you use as long as you identify them in the key. I already have my key taped down. I don't have my other one yet because I want to be able to look at step 5 and follow that one. So step 5 says to unzip the strands of DNA molecule and unfold each strand, revealing the new strand. So in replication means to copy itself. So in order to do that, first the DNA must unzip. And the reason it unzips is because this bond between them, the hydrogen bond between these bases, isn't really that strong. And so we have this little enzyme that comes through. An enzyme is a protein that helps reactions, and it comes through and it cuts through the DNA and splits them apart. So now you can see that they can split apart. And once they are split apart, then what happens is nucleotides that are floating around, new bases with the phosphate and the sugar, they're floating around in the nucleus. They can come in and they can bind to the free side. And so if you look over here, the C, what's going to end up binding to it is a nucleotide with a G. The T is going to bind with a nucleotide that has an A base, and so on. And so when you unzip it, after you unzip it, you can replicate it. You can finish copying it. And so now you'll see that we have a brand new double-sided DNA on the left side. And you can do the same on the right side. They can both be replicated. And if you look, you should notice that the new replicated strands are going to be the same as the old ones. Now, on part 5 of the directions, after you unzip the strands of DNA and unfold each, revealing the new strand created from replication, it tells you to use your knowledge of nitrogen base pairing. So those base pairing rules, and fill in the blank nitrogen bases. So that's these boxes right here. So make sure that you do that and color it accordingly. When you are done, you are going to tape it into your notebook. Now, when I say tape it in, only do the top parts. Only do the diagram A, because you want to be able to move these around anytime that you need to review replication and see how they can unzip and how they can form new DNA molecules during replication. And so just diagram A gets taped in. When you are done, this is the notebook that I had from last year, you should see that part A is in there. This can rotate around. Okay, and when we come back out, you'll notice that this strand is exactly purple, purple, blue there is going to be exactly like, whoops, that one fell out, the original DNA strand. Okay, and that's DNA replication, making exact copies of DNA.